Alright, so today we're looking at the remainder factor theorem. Because most of you did Year 10 5.3 and you did polynomials, you would have seen this before. So the learning intention is to gain the knowledge of the remainder and factor theorems and how to apply them with polynomials. So you'll be successful if you obviously can understand what the remainder theorem is, if you can apply the factor theorem, understand a couple of the properties of the polynomials, because that will help you with some of the problem solving, and then be able to factorize polynomials. Okay, so what the remainder theorem says, it says if a polynomial p of x is divided by x minus k, then the remainder is p of k. Yeah, so obviously if this was x plus k, then the remainder would be p of negative k. So let's try. Here's our dividend and here's our divisor. Let's divide this. Okay, we've got x cubed plus x squared plus x plus 4, 3, 2, 1, yep. Let's go divide by x minus 2. Alright, so we know that there's going to be some kind of remainder. Let's figure it out. So x into x cubed goes x squared, multiply by 2x, subtract them together, that disappears. 1 plus 2 is 3x squared, plus x, so plus 3x, 3x times x is 3x squared, minus 6x, subtract those two, 1 minus 1 is plus 4, alright, so plus 7, so we get 7x minus 14, minus minus, so it's plus, I get 18. Okay, so let us find out what p of 2 is. So that means, and the reason why it's 2 is because of this. So if I got a factor of x minus 2, the actual term is actually 2. Okay, so p of 2, well that's 2 cubed plus 2 squared plus 2 plus 4. That's 8 plus 4 plus 2 plus 4. So that's 10. 4 plus 4 is 18. So p of 2 is equal to 18, which is also the remainder. So if a polynomial p of x is divided by x minus k, then the remainder is your value. Okay, so that's the remainder theorem. So maybe put in here, if p of x is divided by x minus k, the remainder is p of k. Okay. All right. The factor theorem. Actually, that should be next. Sorry. Okay. For a polynomial p of x, if pk equals 0, then x minus k is a factor. Okay. So let's do an example. Here we have the polynomial x cubed minus 7x squared plus 8x minus 2. To find a factor of this polynomial, I need to be looking at this last term and finding the factors of negative 2. So I ask myself, what are the factors of negative 2? So that includes 1 and 2 plus or minus, basically combinations, right? So let x equal, let's say 1. So what does p of 1 equal? So we're going to plug it in. So we've got 1 cubed minus 7 plus 8 minus 2. So so negative 7 plus 1. So 1 minus 7. 1 minus 7 plus 8 minus 2. We get 0. Excellent. Perfect. That's what I wanted. I wanted to find a factor of this. So it means x minus 1 will be able to be divided into that. Because if x was 1, I get 0. Yeah. So x minus 1 must be a factor of this. So x cubed minus 7x squared plus 8x minus 2 divided by x minus 1. So, and the reason why I want to do this is because I want to find the other factors. Minus x squared. Sorry. Okay, so that disappears. Negative 7 plus that's negative 6. So negative 6x. Negative 6x squared plus 6x. Now I'm going to minus those together. That disappears. 8 minus 6 is 2x. Minus 2, we get minus 2x plus 2, sorry, 2x minus 2 gives me 0. So it means I've got, if I want a product of its linear factors or linear parts, I've got p of x now equals x minus 1 multiplied by x squared minus 6x plus 2. Now I can't factorize that any further, so that is that's my final answer. Okay, so if you can find a factor, if you plug it in and it gives you 0, right, then that thing x minus k is a factor. So if p of x is divided without it nicely or perfectly by x minus k, then p of k is a factor or a 0. Okay. So some of the properties that you need to know. If I have n distinct roots, k1, k2, k3, all the way to kn, then I can factorize your p of x into x minus k1, x minus k2, x minus k3, all the way to x minus kn. And they're the factors of p of x. The degree of n and the roots is equal to an x minus k1, x minus k2, x minus k3, then x to the kn. Okay. A polynomial of degree n can't have more than n distinct roots. So if I have a polynomial of x to the power of 3, I can't have I can't have 4 roots. I have 3 or less. Yep. A polynomial degree of n with more than n distinct roots, the only time that's possible is when I have the 0 polynomial. 0x to the n, 0x to the n minus 1, plus 0x squared, plus 0x plus 0. Now, if two polynomials of degree n are equal for more than n distinct roots, right, then the coefficients of the like powers are also equal and real, okay? So if I have a polynomial and it's it's congruent to another polynomial, well then these terms are also equal. I've got an example to show you about that. Okay. Let's do a couple of questions. We want to use the remainder theorem to find the remainder of this. Well, if I'm dividing this by this, right, my term would be negative 1. I just want to plug in what that is. So 3 lots of negative 1 to the power 4 minus negative 1 cubed minus negative 1 squared minus negative 1 minus 7. Okay. So negative 1 to the power of 4 becomes a positive, so that becomes 3. Negative 1 to the power of 3 stays as negative 1. With a negative, that becomes positive now. Negative 1 squared becomes positive, so that stays, so negative 1. So the two negatives make a positive, minus 7. So 4, minus 3. They should cancel out. 4 take away 3, yeah. So, yes, good. Okay, minus 3. So the remainder is negative 3. All right, find the value of k if the remainder is negative 14 when this whole polynomial is divided by x minus 2. Well, same thing. So I've got p negative 2. I'm going to plug this in. So negative 2 to the power of 3 minus k minus 1 negative 2 squared plus 5k of negative 2 plus 4. Now this whole thing equals negative 14. So let's just clean this up. Let's be negative 8, 4k minus 1 minus 10k plus 4 equals negative 14. Okay, cleaning it up some more, expanding this, I've got negative I'm going to take that negative 8 to this 4, so that's negative 4. Okay, so it's negative 4k plus 4 minus 10k, so that's negative 14k. That 4 disappears, that equals negative 14, so our k here equals 1. Okay, and that's just doing some algebraic steps to get there. Okay, if x minus 2 is a factor of this polynomial, is x minus 2 a factor of this polynomial? Well, let's check it out. So, does p of 2 equal 0? Let's find out. 2 cubed minus 4 lots of 2 squared plus 2 plus 6. So that's 8. 4 by 4 is 16. Plus 2 plus 6. So that's negative 8 plus 8. So yes, it does equal 0. So it is a factor. So if I want to write it as a product of its other factors, what I'm going to do is divide this by x minus 2. So that becomes negative 4 plus 2 negative 2x squared. So that's minus 2x. Yeah, that becomes negative 2x squared plus 4x. Subtract those two. So 1 minus 4 is negative 3x. Now, this solution here is going to have to be 0, right? So for it to be a factor. So negative 3x, that's plus 6. You minus the 2 together, it does give you 0. So this f of x is really x minus 2 multiplied by the quotient, x squared minus 2x minus 3. This is a quadratic, so we should be able to factorize this as well. In this case, we could. So x minus 3, x plus 1, minus 3, yep. And really, we kind of like to have them in order of the roots that they're going to appear left to right. Yep. So from negative. Okay. So, last question. We want to evaluate A, B, C, D if this polynomial is equal to this. It's similar. Sorry, it's congruent to this. Yeah, the three equal lines means congruency, so that they're equal, they're congruent to each other. So to do that, what I'm going to do is I'm going to expand the right-hand side. X plus 1 all squared is x squared plus 2x plus 1 plus bx plus 1. I'm going to times everything out, so expand again. But ax squared plus 2xa plus a plus bx plus b plus c. And what I'm going to do is now write this in terms of the x's. So here I've got x on the outside, so I need 2a and I need a b. Alright, and then the a, b, c is the constants at the end. Now this is similar to this. So the coefficients must be similar. So x squared here is 1, so a must be 1. So the coefficient of x is actually 2ab, and that equals 4. Now we know that a equals 1, so that's 2 plus b equals 4, b equals 2. Okay, now the constants, a plus b plus c, must equal to negative 3. We know that a is 1, b is 2. Okay, so that's 3 plus c equals negative 3, so c equals negative 6. Okay, so I could write it as x plus 1 squared plus 2 lots of x plus 1 minus 6. Okay, and that's it for today. All right, good luck.